Hello, this is a full tutorial for Agisoft Photoscan Professional. I wanted to bring you guys through the entire process, at least to generating a dense point cloud. So basically I have Agisoft Photoscan open with no data. First step is workflow. You're going to add some photos. So I have an existing project. These points are 80% overlap, 80% side lap. And these are the photos I'm going to start with. So you can see the photos are toggled on in the top menu bar with the photo icon. So you can toggle them on and off if you want to see them. And the next step we're going to do is actually reproject these photos from WGS 84 latitude longitude to state plane coordinates. So go ahead and hit the convert button, not the settings button. So the settings button is actually for assigning a coordinate system, and I have another video tutorial on that if you're interested. Actually go to convert. This is going to convert these coordinates that are given from the EXIF tags. I'm going to go ahead and use Wisconsin Central. That's EPSG 2929. Go ahead and select that. So once you get that selected, you'll see that it actually reprojects these into that state plane coordinate system zone, which is going to be very helpful when we bring in our ground control, because they're basically going to line up pretty close to the ground control points. So once you get that converted, the coordinates converted, you can go ahead and align the points. So this takes a little bit of time. I'll fast forward that, but first thing I'll go over is the key point limit. Through trial and error, I've settled on 240,000 for the key point, and the tie points, I actually don't limit those at all. So placing a 0 in that will actually not limit the tie points. I've had the best luck with this, especially with high megapixel cameras. If you get a 30 plus megapixel camera, you're going to need more key points and tie points enabled. So go ahead and hit OK. It'll start processing. I'm going to fast forward this for you guys so you don't have to watch the entire status bar. Now, I like to look at the details and kind of see what's going on. Okay, through the magic of video editing, I'm going to be back with you guys in real time speed shortly. All right, here we are. So this has generated what's known as a sparse cloud for our project. And we could kind of zoom around. You're going to see there's some points, but it's not a dense cloud by any means. It's just kind of the first step towards the dense cloud. So the next step is actually to go ahead and import some ground control points. So to do that, you go to import. I have a GCP file, right, in data city slip. There we go, GCPs. And here we are. So I'm going to go ahead and select this one. And now you see the previews in the bottom. And I believe this is an XYZ file. So I'm going to go ahead and change these labels to be column 4, change the easting to be column 1, change the northing to be column 2, which it is, and then altitude or elevation should be column 3. So that's X, Y, and Z. And I can confirm this by going up and looking at the projected coordinates on there. So here I have the northing is 253. Easting is 248. So yeah, it's actually not. It's actually in northern easting and elevation. So northern column 1, easting column 2. Now it matches up northern. Okay, good. So I can go ahead and create those. And being I don't have them in the project, I'm going to hit yes to all. So there we go. We have our points created. And here's a tip, guys. If you ever want to get back to the top view, you can go ahead and hit the 7 key. So if you hit the 7 key, it'll actually bring you to a top view, kind of north up. And then if you go somewhere else and kind of pan around and you want to go back there, you can just hit the 7 to get back there. That's a good tip. And another one, if you look up on the top left of the model view window, you'll see I'm at a perspective view. And then pressing 5 actually toggles with orthographic. For this process and a lot of the aligning, I recommend orthographic. Perspective is a cool view. It's more 3D, but it's not as practical for things like matching points. So I'll leave it at orthographic. And now I'm going to head up here to markers, detect markers, and it'll actually detect these cross markers that I have on the ground. And I've found good luck with 50 and 10. I'm not sure if they're default, but you can adjust those for your given data set. So now I'm going to go ahead and let the computer detect markers. So it's actually looking through all of the photos and trying to recognize that cross shape, which is a ground control point pattern. And when it's done, I'll go through a couple photos and show you what it's recognizing. It does a really awesome job. So now you can see there's actually duplicate points here. And I'm going to go through a process of actually renaming those generated points to our existing ground control point numbers. And kind of bear with this video. I think you'll see why I'm doing this here at the end of this. So I'm going to rename that point 1, and then this one here. Another tip for you guys is toggling that selection back and forth is the space bar. So that's going to be helpful too. Oops, not 25, it's actually 0.2. There you go. I'm going to go up here, select that one, change that to 0.3. Oops, selected there by accident. So here, go ahead, grab those. Yep, so change that point to 0.4, these auto-generated ones. There you go, 0.5. Here's another one, 0.6. And then 0.7 seems to be kind of stray. I think it might be a control point outside of the project boundary. So I'm going to go ahead and wipe that 0.7 out. We don't need that 0.7. So go ahead, just right click and remove it. Go ahead and remove it. Now you can see we have duplicate point numbers. So I'm going to sort these by easting. Now all of these on the bottom were imported already from our file. So I'm going to delete those. Now all that's left are these auto-generated ones. The problem is there's no northings, eastings, or elevations associated with those. So now we're going to re-import that ground control point file. Now you can see that the same thing we did. Now it didn't ask to create new ones because they already existed. So now it just assigned the northings and eastings and elevations to all those. Now it can zoom in. Now this is what it's recognizing automatically. So I think Edgesoft does a great job recognizing these non-coded targets. I haven't heard of people having very good luck with the coded targets at drone elevations. Maybe for an archaeological site or something they work, but for the drone application, these non-coded targets seem to work pretty great. I'd like to hear your feedback also. So another thing I recommend is going ahead and selecting this little yellow triangle that shows you your accuracies. So you can see some of these are, a little bit up there, but if you go ahead and update those and then optimize here, and I typically use adaptive model fitting and then estimate tie point conversions. So I'll let this run. This takes a few minutes, and ultimately what this is doing a kind of a constrained adjustment on those points. So you'll end up with should be much better estimated error accuracies for your control points. A lot of times I'll open that details just to make sure that the program's still running and that we have good progress being made. So this generally goes kind of quick. It seems to underestimate the processing ability of the computer at first, and it does seem to speed up pretty well. So again, guys, this is kind of a lull in the video, so I'll take this time to say if you're finding value in these videos, just like the videos and subscribe to the channel. So now you can see those accuracies are much better. You're down in the neighborhood of 1/100th, 2/100ths of a foot, which is about an eighth to a quarter inch of estimated accuracy. So it's really constraining these and tying them to the ground control very accurately. So the next step here, the final one of this tutorial, is go ahead and build a dense cloud. So I generally don't recommend using ultra high, but in depth filtering, if you guys have any really good advice there on depth filtering, feel free to comment below. And I'll typically calculate point colors. I don't know how much time it adds, but it really does help the view. So I'm gonna go ahead and kind of increase the speed of this video and actually cut out a little bit of it just so we can get to the end and take a look at that dense cloud. There is an option to do network processing as well, actually on a hosted computer by Agisoft. I have another video outlining that procedure. I encourage you guys to use it. It really does save a lot of time, especially if you don't have a really big graphics card. Okay, here's the final result. So this is the dense cloud processed with ground control, and I'll kind of zoom in here and take you guys around these piles, and then you'll get a pretty good idea of the density and the quality of this point cloud. It's really good. I've noticed that when they switch from PhotoScan to Metashape, it's really improved the quality of these point clouds. Very good. So that's as far as this video is going to go, guys. I have other videos that are going to guide you guys through the process of building a mesh and a DEM. If that's of interest to you, please check those videos out. And it'll zoom in here to see the quality of that dense cloud and how it creates the uh, the colors that show that target. Thanks, guys.